Hey guys, I hope that your weekend is going well. We're going to start off the week by talking about something called parent functions, which is just exactly what it sounds like. It is the function that is the parent to all other functions. So it's the function that is the one that all the functions of that type come from. We're going to talk about two specific types. So here we go. First problem. It says to use your calculator to complete the table for the equation y equals x. Then we're going to plot the points on the coordinate plane. I'm going to show you how to do this on your calculator, but then I want to talk about how you can do this even without. So if you pull out your calculator, we want to complete the table for the function y equals x, or the equation y equals x. If you will look underneath the screen on your calculator, I apologize for that. Apparently the Rangers just scored and I got an update. So to graph or do something on your calculator, we have to go to y equals, which if you look at the buttons right underneath your screen, you will see that y equals is this button to the far left. If you press y equals, you see all of these y equals. It means the reason there's a bunch is because I can graph several pictures at the same time. Mine has something in there, so I'm going to hit clear. Right here in y1, we want to graph y equals x. Well, the y equals is already there, so all I have to do is tell it x. If you will look right to the right of the alpha key, there is a button that has all these letters on it. The first letter on there is an X. If you push that button, you have an X. So I've entered in my equation y equals x. I want to look at the table for this so that I can finish filling in my table. To find the table, if you look again right under your screen, the button to the far right says graph, but above it in blue, it says table. So if I press the blue button, or the second key, so I press second and then graph, it brings up my table. My table on my notes starts at -2. This one here starts at 1. If for some reason yours doesn't start at 1 and you want it to start at 1, here's how you make it happen. You press second and then window, which is another button right under your screen, and you will have this menu. And you just have to tell table start to equal 1. Okay, and so as long as that equals 1, you're good. And to go back to the table, you press second and graph to go back to your table. Now my table though starts at -2, so I'm going to arrow up because that's the direction my negatives are in this table, so that I can see -2. And what you should notice is that as you go through this table, x is always the same thing as y. That's because my equation is y equals x. So without having to use my calculator, I can fill in this table because I know that y equals x, so that whatever x is, y is also. So there's my table filled in. I can get it from the calculator, or I could just use the equation. So we're going to plot these points on our graph. You can just sketch a graph. It doesn't have to be 100% accurate, but you need to sketch a graph so you have a sketch of what this looks like. So I have -2, -2, -1, -1, 0, 0, 1, 1, 2, 2, and 3, 3. And if I connect these points to make a straight line, I'm going to put arrows at either end because it does continue on in both directions. And so the arrows show that it goes on forever in both directions. That's my line. So characteristics of this, first of all, it is a straight line. That's important. Because of this equation, the way it is written, and because it just is x, and it's not anything, it's not x squared, x to the third, x to the fourth power, there's no exponent, it makes it a straight line. The other thing is it passes through the origin, which if you will remember is the 0, 0 point right there. So it passes through the origin. And the other thing that I really want you to notice is that it increases from left to right. You can have a graph that has these two characteristics but decreases. This one has to increase. So it increases from left to right. That's how we read graphs. This right here is the equation for your linear parent function because it makes a straight line, and every other linear equation, linear graph, is written in some form of y equals x. It could be y equals 2x. It could be y equals 2x plus 4, but it is in some form of y equals x. And this is always, always what the graph looks like because x is always the same thing as y. So this is your linear parent function. You need to write down that equation, and you need to know what that equation is and what it represents. Because if I ask you what is the linear parent function, you need to be able to immediately tell me y equals x. And then you need to also know that what that means. It means it's a straight line that increases and passes through the origin. Those are important things. So let's do another one. This one says to use our calculator to complete the table. I'm not going to go to the calculator this time because we can do this basically in our head. We're going to fill in the table for this one, y equals x squared. So that means I have to square x. And to square a number, I do that number times itself. And so the first value is -3. Well, if I do -3 times -3, that's a positive 9, because two negatives make a positive. That means -2 squared is 4. -1 squared is 1. And 0 squared is just 0. 1 squared is 1. 2 squared is 4. And 3 squared is 9. So I've just squared all my numbers. We're going to plot them on here. I have -3, 9. -2, 4, -1, 1, 0, 0, and then the positives of that. And so you see it makes this pretty little curve, just like this. I don't draw very well, but it does. It makes a pretty little curve that starts over here to the left, comes down to the origin, and then goes back up and goes to the right. It has arrows on the ends because it is also going to continue on forever. This graph that makes this shape is called a parabola. You only get a parabola when you have what we call a quadratic function. And what makes it quadratic is this, that's a parenthesis, is this x squared right here. And so this is the graph of the quadratic parent function. So let's talk about the characteristics. Number one, its vertex, which is its turning point. It's the point at which it changes direction. It's called the vertex right here. That point right there is the vertex. Fancy word. The vertex is at the origin. That's very important. The vertex has to be at the origin. Another thing that you should notice is that the y-axis cuts this parabola 100% completely in half. So it is, the y-axis is right smack in the middle, and everything on the left side of the y-axis is the exact mirror images of everything on the right side of the y-axis. So it is its line of symmetry. So the y-axis is the line of symmetry, which is important. Another thing you should notice is that this parabola opens upward, which means, I mean, it opens up as opposed to opening down. And so those are characteristics of that graph, and they're the important things. The vertex at the origin, and the y-axis is the line of symmetry, and it opens up. This right here is what we call the quadratic parent function. So every quadratic function, every quadratic graph is in some form of y equals x squared. It has an x squared in it, okay? It doesn't have any exponents higher than an x squared, but it's got an x squared in it somewhere, and it's in some form of it. 2x squared plus 5x. It has some form of x squared. So let's practice this for just a second. I have three graphs, and I just want to determine if they're linear, quadratic, or neither. So do they make a straight line? Do they make a parabola? Or are they neither one? So look at number 3 here. If you look at number 3 is clearly a straight line. Therefore, it has to be linear. Number 4 looks a lot like our parent function over here. It's just moved down a few spaces, but it does. It makes this pretty little curve, this pretty little U. So it's a quadratic, makes a parabola. So this one is quadratic. If you look at number 5, it's not a straight line, so I can't call it linear, but it does curve. However, it's not a pretty little U curve like our quadratic. It curves twice. It curves here, and then it comes back around and goes the other way. This one is a neither. It's not the kind of function we're going to study in Algebra 1, so we just call it neither for now. All right, number 6 asks, which equation is the parent function of the graph represented in problem 4? Well, if you go back here to problem 4, we labeled it as a quadratic graph, which means that the parent function has to be the quadratic parent function. And if you will go back in our notes, you will see that the quadratic parent function is y equals x squared. Again, another one you need to know pretty much by heart. Okay, so this is the quadratic parent function. So the graph that goes with problem 4, or the equation, is y equals x squared. Now number 7 has 4 equations, and we're asked to determine if they are linear, quadratic, or neither. There are a couple ways to do this. Number 1, you can put it in your calculator and see what it looks like. Number 2, you can relate it back to either of our parent functions. The linear one, it's got to be in some form of y equals x, or the quadratic, some form of y equals x squared. So number A, letter A, says y equals 2/3 x equals 14. Well, this is some form of y equals x. It just has extra stuff. It's got the 2/3 and it's got the plus 14, but it still has the y equals x as its base. And I mean, and we just multiplied it by 2/3 and added 14. It changes the way the graph looks, but its parent function is y equals x, so that makes this linear. Part B does not have a y in it, but that does not make it a neither. This right here, and here's what I notice. It has an x, so it could be in some form y equals x, but it also has an x squared. So it also could have some form of y equals x squared involved in there. It also has this -3, but there are no exponents higher than x squared. The highest exponent in this equation is the x squared, which makes this a quadratic function. If I were to graph it, it would make a pretty parabola, just like the one that we talked about before. Now look at C. C has an x, but it also has an x squared. It also has an x to the third, so it has an exponent higher than x squared, which means it can't be linear and it can't be quadratic, so this one has to be a neither. Now part D. Part D has 2 x's. It's got a 2x and a 2x, so let's simplify it. Let's put those together. 2x plus 2x is 4x plus 5 equals y. There's an equal sign there. And so this now is some form of y equals x. It just has a times 4 plus 5, but it is still some form of y equals x, so this one is linear. That is parent functions. That's the basis of parent functions. The 2 things you must absolutely remember. Y equals x is your linear parent function. Y equals x squared is your quadratic function. And everything else linear is in some form of y equals x. Everything else quadratic is some form of y equals x squared. You guys have a good rest of your weekend. I will see you tomorrow and we will practice some of this. Please do not show up without notes tomorrow. You will not have much fun if you do. Okay? Have a good evening. I'll see you then.